Hello. In this podcast, we're going to take a very quick look at power and how it relates to work and energy. Let's get started. Power is defined as the rate at which energy is transferred or the rate at which work is performed. We're going to be especially interested in this latter definition when studying mechanics. The units for work, it's given a special name, watt, in honor of James Watt. It's a joule per second since it's energy transferred per unit time. And in base SI units, it's kilograms times meters squared divided by seconds cubed. There's two ways of defining power. We have average power, and that's equal to the work divided by the elapsed time. We can just go ahead and make a substitution here. And what we wind up with is average power is equal to the force times the average velocity. So when we're doing work to move something, we can determine the average power by taking the force times the average velocity, or we can use this version. If we know the total amount of work done over an elapsed time, we can find this quotient. We can also calculate instantaneous power, and that's dW dt, the rate at which work changes with respect to time. And we can make a similar substitution here. And what we wind up with is for instantaneous power, it is equal to force times the instantaneous velocity. Or if you have an equation for work, you can take the differential of that equation with respect to time to calculate the instantaneous power. Let's take a look at a few problems. We have a 100-watt electric motor. Notice this is a power rating because the units watt are for power. This motor lifts 100 kilograms safe at constant velocity. Question here, how high can the motor lift the safe in 10 seconds? Well, for this one, we'll go ahead and use our average power, and we'll assume that the power being exerted over this time is 1,000 watts. After we rearrange the equation and plug in the numbers, we find that this motor can lift the safe 10.2 meters in 10 seconds. Here's another problem. A crane lifts a 5,000 Newton crate at a constant speed of 4 meters per second. At what rate is the crane performing the work? In this case, we want to use our instantaneous power, and we're going to use it in the form of force times the instantaneous velocity. We plug in the numbers and we find out that the work is being performed at a rate of 2,000 watts or 2,000 joules per second. Well, this ends our podcast on power. I hope you found this helpful and have a good day.